Hey, good morning, everybody. My name is Brent Brunell, so I'm the Additive Technology Leader here at the Research Center. Welcome to day 2 of the 2019 Edge Controls Symposium. Yesterday was a great day. We're going to have the first part of this morning be around additive technologies. I'm going to have myself and Tom Kerfus talking this morning. Here's Tom. Hey, this is actually, I think, the 17th time I've talked in the front of the symposium, so hopefully I'm getting better at this. I want to talk about a lot of great work that has been done across GE for additive. So I'm going to show things that aviation has done, things that power has done, the Research Center and GE Additive. So this is a lot of people's work I'm going to be sharing with everybody. So before I get to talk about what GE's been doing and where we're going, I want to first start with kind of where does manufacturing come from, and I tell this one rocks to replicators, right? So if we go back 3.5 million years ago, we were trying to manufacture things. It wasn't us, it was our people before Homo sapiens. They were doing it with rocks, breaking things apart, right? The big, huge technological leap was, hey, we figured out how to not only have fire, we figured out how to control fire and use it for different purposes. That was about 5,000 to 7,000 years ago. We figured out how to work with metals. So the Bronze Age, Iron Age, we've all heard of it, right? It was, hey, I can start to do things with fire, start to work with metal, forge it, figure out how to cast it. And so we've been working with those forged and cast capabilities for a couple thousand years. Where manufacturing and controls really hits each other was about 200 years ago, right? So James Watt, with the invention of the steam engine, that wasn't the important part, was the invention of the flyball governor in 1788. That was one of the last year's quizzes, so if anybody remembers the quizzes from last year, so that was that one. They needed a control for 2 reasons. One is to make sure that they could maintain safety of the equipment, not blow it up. The other is maintain safety of the people around them. So controls has been there to regulate and keep things safe for over 200 years. Very shortly after that, they came up with this thing called the steam hammer. The steam hammer is, hey, you got a very heavy, essentially anvil, big hammer. You use steam to raise it up. You hit the button, boom, the thing falls down. I'm able to forge metals. All right, big step. The big step was I went from the day before that, I was modifying characteristics of metals with my hands. Now I'm using big machine tools to start to move this production capabilities, game on, right? Then we step into, hey, we did that for a couple thousand years. I think we figured some things out about those things. Now, talk about additive, only in the last 30 years, right? So 1987 was the first additive commercial printer. So it's 3D systems, right? So they're using plastics, and they printed a part, and we're able to do things that way. The big change was we went from kind of these bulk, relatively slower processes for making materials, metals, and our pieces, to I'm building this part, micron by micron. Complete change, right? So when they started to get into metals, so metals was somewhere in the 90s, starting into metal manufacturing. Now you're taking metals at the 50 micron, 100 micron range, so the size of your hair, half the size of your hair, and you're assembling those pieces together to build up what you want. A lot of things happen. I'm going to bring out a lot of details of what's happening right at that point of that process. But if you think about what's from a time scale and from a size, you got the size 50 microns. The time scale is you heat the metal up and it solidifies in 1,000,000 degrees per second. So it's about 1,000 degrees into thousandths of a second, so 1,000,000 degrees per second type of rates. That is not anything that we've worked with prior. So now we as a materials community, we as a controls community, we as a design community have to figure out how to work with this new system, how to get it under control, and how to build the parts that we want to use for our systems as we move forward. That is inherently a digital process, right? I want to build it up micron by micron. We call it, in paper, you call it pixels. On screens, you call it pixels. In parts, we call it voxels. So those voxels are these 50 micron, you can define it any size, but say it's 50 micron. These work out to be big numbers really fast, right? So if I go a 50 micron size voxel in a 1 meter by 1 meter by 1 meter part, it's 10 to the 12th voxels. From an additive point of view, I could turn on and off any one of those 10 to the 12th voxels, right? From a data point of view, if I just assign 32 bits per voxel, it's 32 terabytes for one part, for 32 bits, right? These are big numbers really fast. So we're going to get into, hey, this is fast, it's 1,000,000 degrees per second, it's small, it's big data. This becomes a challenge for the edge and controls community as we move forward.